So last time we had a look at the dynamic programming algorithm and the components of the algorithm and how they go together to maximize the net present value of the project. In this video we're going to be looking at some sample calculations of how this works in practice. So let's have a look at our 10 increments of rock, and we're going to be using this backwards dynamic programming algorithm. Now what we're going to be doing is we're going to go to the last increment of rock. So at the last increment of rock, we're going to do the calculations of the cash flow from a little bit of the resource plus the value of the remaining resource. And we're going to be looking at 3 different cutoff grades. The first one is our high grade cutoff grade. So we have a cash flow of $10 and our remaining value is 0. It would normally be the closure cost, but in this case we're assuming no closure costs, so we have a remaining value of 0, and our total value for the entire resource is 10. For the medium cutoff grade, we have a cash flow of 20, our remaining value is still 0, and so our total value of the entire resource is 20. And likewise for a low cutoff grade, we have cash flow of 30, giving us a total value for the resource of 30. For those 3 options, we look at the maximum value of the entire resource, and we come down and find that the best cutoff grade is the low cutoff grade, of giving us a total cash flow of 30 for the project. Now we skip back to the second last increment of rock. So at this point, we go through our 3 cutoff grades again, our high, medium and low cutoff grade, and we're assuming the same cash flow for each of the cutoff grades. But here's where we have a different remaining value. So for the high cutoff grade, we just calculated that our remaining value is 30. For the medium cutoff grade, instead of being 30, the medium cutoff grade takes a little bit longer to mine, and therefore it pushes back the remaining value, and so it delays the remaining value. So the remaining value has come down from 30 down to 27. And then for the low cutoff grade, we have the same situation where we have a higher cash flow, but our remaining value gets pushed back even further. So the remaining value is now 25. So if you sum the cash flow plus the remaining value, you get the total value. You pick the maximum one, which is the low cutoff grade again. And now we know the best cutoff grade decision for the second last increment of rock. Now if we continue back through the mining sequence till we get to a point where the remaining value is $300. So if we have a look at the same 3 calculations, if we have a high cutoff grade for this block, then we have our $10 plus our remaining value of 300, our medium grade value of 20. The $300 remaining value gets delayed because the medium increment takes a little bit more time and pushes that material back. So that's 270, and the low cutoff grade being 30 pushes back the remaining value even further, so we have $250. We add up the cash flow plus the remaining value. Now we find that the best cutoff grade decision is the high cutoff grade. Okay, let me show you this graphically. Here we have a chart of the 10 different increments of rock, and the cutoff grade in each increment is shown by the dotted blue line, and the blue is how much material would go to the mill at that cutoff grade, and the grey would be how much material is being mined as rock during that year. The net present value of the schedule is shown at the top here, and the life. So this will start at the last increment and move forward through the increments until we get to the first period, the first increment. So as you can see, as it moves from the back of the schedule to the front of the schedule, we get a generally declining cutoff grade. It's not completely declining, it's called a variable cutoff grade because sometimes it goes up and sometimes it goes down. But on average you can see a declining pattern to the cutoff grades. And you can see now we have our maximum NPV is 1875.5, which took us 18.01 years. Now there's a lot you can do with this algorithm. You can look at various cost changes, different prices, different resource distributions, and a lot of those changes you can look at using COMET 1. In the next video, we'll be looking at a forwards dynamic programming algorithm, which overcomes some of the limitations of this algorithm. We'll see you then.